Hello listeners, I am Dr. Anuj Sharma from Center for Advanced Studies, which is in campus research driven institute of Dr. APJ Abdul Kalam Technical University located in Lucknow. So, we are discussing the fundamentals of mechanical engineering and mechatronics first year subject KME 102T oblique 201T. So, it is common subject to all. So, in today's lecture we will discuss the numerical problems on stress and strains. So, because we have till now understood the concept of stress, strains, various elastic constants and the deformation of the rods. So, now we understand some concepts and now we will try to implement the learned concept to solve the simple numerical problems. So, we will take few numerical problems. So, I will also discuss some formulas which you will have to derive by consulting the different textbooks. These formulas are very simple, but I will discuss in brief here, then we will take the numerical problems, right. So, elongation of bar means a rod. So, you will see, so there are some important formulas which I am going to discuss here. Let us say this is the bar whose cross section is, let us say this is the length L and the cross sectional area means this cross sectional area is A, right, and the modulus of elasticity of the material is E. So, this is the modulus of elasticity. So, let us say we apply some force here and we want to calculate the elongation, right. So, what would be the elongation? So, delta L for this case, that will be equal to P L upon A into E. So, you can derive this formula. It is very simple formula, comes from the Hooke's law. So, you can put P L upon A, you can easily get the derivation this. Now, the second case may be, so let us say, or I should say, just a minute, it is okay. So, let us say this is the rod and this is the length of this rod and the total weight of rod, let us say it is W, and the cross sectional area, let us say if we will see from here, let us say it is circular or rectangular, whatever it is, but let us say the total cross sectional area is A and modulus of elasticity of this material is E, right. So, it means the delta L in this case due to its own gravity. So, we are not applying any external force here. So, what is responsible for the elongation of this rod? It would be elongated due to its own weight under the gravity. So, for this we also have formula W L upon 2 A E. So, this formula we have to remember. So, these formulae we should remember. Now, the third case may be, let us say we have this rod. So, let us say this is the if you will see the cross section of this object. So, let us say it is circular and this is the tapering bar. So, from here let us say the diameter is capital D and here the diameter is small d and the total length of this rod is L. The modulus of elasticity E. So, the delta L means we are applying some force here, let us say this force is P. So, what would be the elongation? So, elongation will be equal to 4 P L upon L means this is the length pi E capital D small d. So, these formulae we have to remember. We can derive these formulas also, but I do not think so this is important to discuss here, because it involves very simple geometry. So, you can refer any standard textbook. So, there are many textbooks prescribed in your syllabus. You can go through those textbook and you can derive these formulas to understand very simple formula, because you might have studied these formulae in class 12th or class 11th also. So, you can do this exercise at your home. So, but I request you to remember these three formulas. So, these formulas are very important. So, now we can say we can take the first numerical. So, a steel wire which is 10 mm, just a minute, let me select the color. So, this is the steel wire, this is 10 mm in diameter. Diameter is given, is used for hoisting purposes in building construction. If 150 meter of the wire is hanging, so it means many inputs are given. So, let us say first note down the inputs what we have been given. So, this is the length is given, the steel wire diameter is given, right, and it is hanging vertically. So, this is to note down, and a load of 800 Newton is being lifted. So, it means there is a wire, let us say this is the wire and some load is there, let us say this is 800 Newton is there. So, this is the wire whose length is given, its diameter is given. Determine the total elongation of the wire. So, we need to calculate the delta L. So, this we have to find out. The weight density of the steel is given. So, it is made up of steel. So, weight density is given. If weight density is given, so easily we can find out the total weight of the wire, right. And modulus of elasticity is given 200 giganewton per meter square. So, this is the unit. So, convert all these lengths into the SI units first. 10 mm is 10 into 10 raised to the power minus 3 meter. So, likewise you can convert all these dimensions in the SI units. So, it means it is a case of two cases, it is a mixed case of two different cases, means this wire has some weight, it means it is being pulled down with the weight of this wire also. So, this is the weight of wire also. So, weight is given, that weight you have to calculate first. How? Weight density multiplied by the total volume. So, for volume you can have the wire diameter. So, that is the diameter is given, length is given, diameter is given. So, pi by 4 d square is this area multiplied by total length is the volume multiplied by the weight density. So, you can easily find out the weight. So, likewise you can calculate the weight, simple mathematical calculation. So, now let us start the solving of this problem. The total elongation of the wire is partially due to the applied force. One case is this 800 Newton is being applied here. So, that will also try to elongate the wire, first case, and partially due to the weight of the wire. So, it is a case of two cases. So, elongation due to 800 Newton. So, first let us consider this case. Already in the previous slide we have derived three formulas, or we have discussed three formulas, better to say. So, delta L1. So, it is the elongation in the wire due to this load 800 Newton. So, that would be this formula we have already discussed, PL upon AE. So, this P is 800 Newton is given, L 150 meter is given SI unit. So, PL upon A is pi by 4 d square. So, d is 10 mm. So, convert it into the meter. So, 0.01 meter multiplied by square, right. So, this is the area. So, this is area, and E this is given 200 giga means 10 raised to the power 9. So, when you will apply this, you can get the delta L1, means this is the extension in the length of the wire due to this 800 Newton of load, right. So, because of this you have got this. Now, the second, partial increment in the length due to weight of the wire also. So, this is the second case. So, you can see here elongation in weight, that formula already we have discussed in the first slide, WL upon 2 AE. So, what is the W? W is the weight. So, now W formula we have derived here. So, this is the pi by 4 diameter square multiplied by L multiplied by weight density. So, that formula we have derived there into 150. 150 is the length. So, 150 divided by 2, this is the again area, cross section of the area, multiplied by this is modulus of elasticity, which is given to us. So, very simple straightforward formula based question. So, just do the numericals, just do the simple calculation, you will get 4.387. So, due to its weight, this much of the increment, due to the applied load 800 Newton, this is the. So, if you want to calculate the total elongation, just add these two. So, this is the total elongation. So, this is the answer, 12.03 millimeter, very simple formula, you just try at your home also. Now, let us come back to the problem number 2. So, a steel rod circular in cross section tapers from 2.5 centimeter diameter to 1.25 centimeter diameter in a length of 50 centimeter. Find how much of this length will increase under a pull of 25 kilonewton if E is equal to 200 gigapascal, right. So, these dimensions are given. Let us say there is a tapering rod. So, tapering rod means if I draw this rod, so at one dimension it is 1.25. So, it is the 1.25 centimeter, it is 2.5 centimeter, one diameter here, small diameter here, in a length of 50 centimeter. So, this length is given, that is 50 centimeter. Find how much of this length will increase under a pull of 25 kilonewton. So, here it is pull. So, pull is 25,000 Newton, it is kilonewton, so converted into the this. So, all these dimensions are given. So, we have standard formula, E is given also, this the material by which it is being made up of. So, that E is given. So, you can apply this formula directly, we have derived this formula. So, delta L here they have represented by U. So, no problem. So, delta L. So, delta L is equal to 4 P L upon pi d1 d2 E. So, what I discussed that time formula, that was 4 P L upon pi E capital D small d. So, capital D means bigger diameter, small d is the smaller diameter, but here the capital D means d1, small d means d2. So, that does not matter. So, this is the formula, just put all these things, everything is given to us. So, you can easily solve this. So, put 4, this is P, this is L, length of the rod is given, pi, this is E, pi d1 d2. So, this is 1.25 into 10 raised to the power minus 2, 2.5 into 10 raised to the power minus 2, that has come to 10 raised to the power minus 4, and this is E 210 into 10 raised to the power 9. So, you can easily solve this and you can get the simple solution. So, delta L is equal to 0.2425 mm. So, these are very simple and most of the time these questions will not come, but question will come of which type. Let us see the numerical problem 3. So, this type of numerical problems will come. So, it is the combination of different bars. So, generally we call this case bars in series. So, this is the, or we can say rods, bar means rod, rods in series. So, we have 3 rods. So, find the total elongation of a steel bar as shown in figure subjected to an axial load of 200 kilonewton. So, this is the loading, you can see 200 loading is given. So, this is the composite bar. So, composite bar means we can say it is a combination of 3 rods. First rod is, let us say this, second rod and third rod. So, all the rods are in series. So, load is given, modulus of elasticity is given. So, all these 3 rods which are sticked or pasted together or joined together are made up of same material, that is the steel. So, let L1, L2 and L3 be the lengths of the portions AB, ABC and CD respectively. तो इनकी लेंथ दे रखी है आपको, ये L1 है, ये L2 है, ये L3 है, तीनों की लेंथ दी हुई है. The load is 200 kilonewton. So, load is given to you, right. So, what we can do, let delta L1, delta L2, delta L3. So, what we can do, we can consider this element alone, we can draw the free body diagram of first this rod and we can calculate delta L1. Let delta L1 is the extension in this length. Now, we can consider this rod separately. So, we can determine the delta L2, the change in length in this, and again we can consider this. So, that will give you the delta L3. So, all these three will be given to us. Now, we want to calculate the total elongation. So, we can add these extensions to get the overall extension in the rod. So, let us consider, let us solve it. So, what we can do, we can draw this first rod. So, let us say if we separate out these, we draw the free body diagram. So, this is 200 kilonewton, this is 10 centimeter, right. So, just to balance this, if this particular portion, if you draw the free body diagram, so it is not sufficient. So, it means we have to apply some force, equal and opposite force on the other side. Only in that condition it will feel some elongation, otherwise what will happen to this? It will start moving in this direction, right. So, just to balance this, we have to apply 200 kilonewton. So, now you can see the length is given. So, L1 is given to you, P1 is given to you, right, and area that is given, the diameter of this rod is given 10 centimeter. So, this is by which you can get the area. So, area will be pi by 4 into 10 raised to the power minus 2, means you convert it into the meter square, pi by 4 d square. So, you will get the area A1. So, this is the A1 and E is given, that E is already given to you. So, that is in the previous slide, E1 is given. So, delta L1 would be how much? Delta L1 will be equal to P1 L1 upon A1 E1. So, P1 is known, L1 is known, A1 you can calculate, diameter is given and E1 is given, E1 means E. So, you can get the delta L. So, like this, P L1 upon A1 E, because P is common. Why it is common? Let us see by drawing this. So, just to solve these kind of problems, draw the free body diagram of first block, then draw the free body diagram of the last block first. So, let us say draw this, the third. So, it means 200 kilonewton is given, it is 6 centimeter diameter, you can calculate the area, again it is 200. So, it means P3 is equal to 200. Similarly, if you will draw the free body diagram of the middle portion whose diameter is 8 centimeter. So, here it is 200. Why it is 200? Because when you will draw or split this plane, so due to this, if one force is here, so on this object, if you will draw the free body diagram, you have got this force. So, this is on this side. So, it means this plane and this plane, this is the common plane. So, if we are having one force of 200 kilonewton on this side, so we must have one force on this side. So, that is why here 200 kilonewton, here 200 kilonewton. So, these when you will combine these two portions, they will be cancel out, right. So, here also 200. So, in this situation you can easily see that the all the three portions of the rod separately, this, this and this, they are exerted by the same force 200 kilonewton. So, it means the P1 is equal to P2 is equal to P3 is equal to P in this particular case. So, all these forces are same, that is why it has written P. Now, this rod is being made up of same material. So, it means E1 is equal to Et is equal to E3 is equal to E. So, all modulus of elasticities are same. So, PL upon AE, you can easily put all these values, everything is given. So, you can get the elongation. So, it means 0.0127 mm, this is the elongation in first element. Similarly, in the second, so you can see P is common, L2 upon A2, E is common. So, you can easily solve this simple mathematics, you can get the delta L2. Now, delta L3, P again same L3, A3 or E. So, here you can also. So, this is the elongation 0.0318 in this area and this elongation is in this area. So, what would be the total overall elongation? So, overall elongation you can add all these three. So, if there would be some compressive force you can easily find out. So, that would be subtracted, we will see that in the next numerical also. So, you can see here you can combine all these three, you can add all these three to give the total elongation. So, this is the total elongation delta L. So, likewise you can solve the compound bar or composite bar, right. So, let us go to the next level problem, little bit complicated as compared to the previous one. So, here you can see, so this is the rod steel bar. So, fortunately we have the same material. So, it means E1 is equal to E2 is equal to E3. So, let us say this is 1, this is 2, this is 3. So, first condition what we have got, so steel bar. So, it means E1 is equal to E2 is equal to E3. Now, determine the stresses in each part and the total elongation. So, stress, how will you calculate the stress? Stress means resisting force divided by the area. So, we have to calculate the resisting force and area we have the diameter. So, diameter is given, I suppose 20 mm diameter, that is given. So, for all rods diameter is same. So, just I am drawing the free body diagram and the subsequent calculations you can do, because already we have solved the numerical problem number 3. So, in the same manner you will have to solve this, but just I am drawing the free body diagram, so that you can understand how it can be solved. So, let us split the rod. So, this is 1, this is 2 and this is 3, all the 3 portions are there. Now, the best way to, because here we are observing that different forces are acting in the mid planes also, like here also one force is there, here also one force is there. So, the simplest way to draw or to solve these problems, first draw the free body diagram of either the first portion and then the last portion. So, that is why I am drawing the free body diagram of 1 and block number 3. So, for block number 1, so what is the force on the left hand side? It is 50 kilonewton. So, draw the force here, it is 50 kilonewton. Now, I am pretty much sure if this has to be elongated, so it has to be in equilibrium in the x direction. So, whatever forces you are getting on the left hand section, so the same force you should apply on the right section. So, it means P1 is equal to how much? That is 50 kilonewton tensile. Tensile means positive. So, it is tensile in nature, so P1 is equal to 50. So, now L1 is given, P1 is given, diameter is given, so A1 you can calculate, E is given. So, A, so P1 L1 upon A1 E1 you will get the elongation in the first bar, first section of this bar. Now, come to the last one, do not draw the free body diagram of the middle portion first. First on the left side, then the extreme right side, then we will come back to the middle one. The right side you can see the extreme right face of this bar. So, how much force is there? 40 kilonewton. Just apply this force as it is. So, 40 kilonewton positive. Now, same force it must have on this side. So, apply 40 kilonewton. So, you will get P2 is P3, sorry, it is the third element. So, P3 is equal to 40 kilonewton again tensile. Now, it is up to you, if you want to consider tensile as positive, you can consider these two as positive. So, they will try to elongate the object. So, elongation would be positive or longitudinal strain would be positive. Now, come back to the middle portion. You can take either this plane or this plane, any plane. So, I am considering this plane. So, whatever plane you will consider, you will get the same result. Now, considering this plane, so this is the plane. So, if you will separate out it, so what force it is acting? So, here you will get the same force again, because you are splitting these two planes. So, if while splitting this plane is exerting a force of 50 kilonewton. So, this plane will also have the same force 50 kilonewton. So, apply the same force here. Next, an additional right side or positive x side force of 30 kilonewton is applied to this plane also on the middle. So, it means we have to apply this force, or we can say this force here, and what is that force? 30 kilonewton. So, if we draw the free body diagram of this block, second, so what force actually we are getting on this plane? 50 on this side, 30 on this side. So, what is the net force? The net force is 20 kilonewton on this side. 20 kilonewton, how it has come? 50 in the negative side and 30 on the right side. So, if left side is positive, the right side negative. So, whatever you want to take. So, 50 minus 30 is equal to 20 kilonewton. So, P2 is equal to how much? 20 kilonewton. So, either simply you can apply 20 kilonewton on the other side. So, it will be in equilibrium. Now, you can apply P2, L2, L2 is given, A2 is given, E is given. So, P2 L2 upon A2 E2 you can apply simply, and you can get the elongation in delta L1, delta L2, delta L3 you can add. So, likewise you can solve this numerical. So, I am not going to solve this numerical till the last. So, just I wanted to give you hint to solve this numerical. So, likewise you can easily solve. So, now this is the last numerical of this lecture. So, a bar of 20 mm diameter is subjected to an axial tensile load of, so load is given, bar is diameter is given, axial tensile load of 120 kilonewton is given, which 200 millimeter gauge length is given. It elongates by an amount of delta L is given. So, determine the modulus of elasticity of the bar material. So, E we have to calculate. So, it is a very simple formula based numerical, mu is given, Poisson's ratio is given. So, it is also trying to calculate the change in the diameter. So, quickly I am going through this numerical. So, you can easily, modulus of elasticity is P upon A into 1 by delta L. So, this formula you can easily remember, P L upon A E, वहाँ से this formula has come. So, all the values are given, P is given to you, A is given, you can pi by 4 d square you can calculate, length is given, delta L is given. So, all the 4 values are given, easily you can calculate the modulus of elasticity. So, this is the modulus of elasticity. So, giga-Newton per meter square means gigapascal. Now, Poisson's ratio is delta D upon D and delta L upon L means lateral strain upon longitudinal strain. You can easily remember this formula we discussed in the previous lectures. So, you can put all these values here and you can easily calculate the delta D. So, delta D is this. So, change in diameter it was asking to calculate. So, likewise you can easily calculate. So, this is very simple numerical. So, I hope you have understood the concept of the various fundamentals. So, I hope you will you have enjoyed this lecture. So, do the practice at your home. Thank you so much.